We tend to think that big, long problems are complicated and must be a lot of work, and little short problems should be really simple and be only a little bit of work. But you know, there's never any guarantee. And this particular question with the moviegoers and their score of the movie is a good example of exactly the opposite. In a recent survey, a 21-year-old gave a movie a score of 10, while a 73-year-old gave it a score of 5, and a 45-year-old gave it a score of 7, and a 36-year-old gave it a score of 5. Based on these 4 responses, what is the correlation between the age of the moviegoer and the score for the movie? Really short question? This question is actually a lot of work. Not too terribly difficult, but this question is also an example of a process in which it pays to stay organized. We need to calculate the correlation coefficient. Oh, now wait, correlation coefficient, that's the score for the strength of a linear relationship between two things. First off, in this question, it helps to just stop and make sure that we understand what are the two things we're trying to relate. And they are what I underlined actually here in yellow ink. Apparently there's a hypothesis that the age of the moviegoer, we'll call that X, is related to the score that same moviegoer gave for this particular movie. We'll call that Y. Implying that, and this could very well be, that we think the score the movie gets depends on the age of the moviegoer. Now, nonetheless, what do I mean by stay organized? Okay, we have this anecdotal information. I would like to clean this up into a table. The first part of the table, age and score, X and Y. I'm just going to recopy the information that I was given. Okay, a 21-year-old, age 21, gave a movie a score of 10. A 73-year-old, age 73, gave it a score of 5. Score of 5. A 45-year-old, 45, gave it a score of 7. 7. And a 36-year-old, 36, gave it a score of 5. Based on this, what is the correlation? Oh, now, all right, first off, so far, haven't actually determined anything. I was just copying the numbers we were already given in more of a table or column format. One of the things that I can see right away is the number of observations. The classic abbreviation for that being lowercase n. The size of the sample, the survey that we've taken, n equals 4. Okay, we can see that, right? There were 4 completed surveys. Oh, which, before we go any further, is a pathetically small sample. If we were really interested in reality in this relationship between the age of the moviegoer and what they thought of the movie, I mean, I think we would ask more than 4 people that saw the movie. Nonetheless, for the purpose of just practicing the calculations associated with the correlation coefficient, we'll keep it to 4. Because, now, this is a row. Looks like a lowercase r. The symbol for correlation coefficient. We need the formula for a correlation coefficient. Let me copy it here for our use very, very carefully, because it's complicated. It starts out with, in the numerator, that same n. If you want to calculate a correlation coefficient, you need to say n times the sum of x times y minus the sum of x, sigma x, times the sum of y. Now, wait. Oh, wait, there's more. That is only the numerator. The denominator is even longer. So, I'm going to need to write carefully and compactly in the denominator, that same n, except wait a minute, let me put a little bracket here so we stay organized. In the denominator, n times the sum of x squareds, meaning you square your x's and then you add them up, minus the sum of x, you add up the x's and then you square them, and wait, close brackets, because that's a chore right there that has to be completed. This multiplied by n, again, the sum of y squared minus the sum of y, add them up, then square them. Squeeze in another bracket. That's a chore right there. Oh, but wait, there's even more. These calculations are all under a nice big square root that's in the denominator. This is the formula for a correlation coefficient. All right, the only thing we need to do is just fill in these pieces concerning the data that we do have on the moviegoer age and the moviegoer score. Oh, right, and we said that, right, the x's would be the age and the y's would be the score. We already know what n is. N equals 4. A 4 goes there, a 4 goes there, and a 4 goes there. What we need to do next, staying organized, is find these other so-called summary statistics first. Summary statistics. Some of them are really easy. Like this is the sum of x. That just means add up this column. Add up the ages. The sum of x, I get this adds up to 175 right here. Okay, so we've got what goes there and what goes there. The sum of y, I get that this adds up to 27. Okay, so we have that, and we have that right there, had that, have the n. What don't we have so far to fill this in? Oh, the sum of x times y. Okay, what this is, we can calculate it, the sum, sigma, of x times y. That means you want to take each xy pair, multiply them first, then add them up. So for instance, you'd say 21 times 10, the age times the score, plus 73 times 5, the age of the moviegoer times the score the moviegoer gave, plus 45 times 7, plus 36 times 5, 36 times 5. All right, remember you always do multiplication first and then addition. I get, what is that? Wow, big number, 1,070. Okay, good. Sum of x times y, 1,070. All right, I have that. Now, that was just that part right there. What else am I missing before I try to fill out this formula? Oh, I need the sum of x squared. What is that? That's where you square each one of the ages. Remember, they're the x's, and then you add them up. So, for instance, I would want to say 21 squared plus 73 squared plus 45 squared plus 36 squared. All right, I did that and I got 9,091. That's just that result. Okay, good. That goes there. And then I also need the sum of y squared. So, same exercise, different column. Say 10 squared plus 5 squared plus 7 squared plus 5 squared. I'm just squaring the scores and then adding them up. Much smaller number. I get 199. I think at that point we have all the summary statistics. Think of them like puzzle pieces. Yes, that we need to complete this formula. All right. At this point, let's piece it together. The correlation coefficient, rho. Okay, so for us it would be 4 in the numerator. For n, times the sum of x times y, that was my 1,070, that goes there, minus the sum of x, that was 175, times the sum of y, that was 27. Okay, that takes care of the numerator. The denominator, now that's a different story. Okay, the denominator, first off, inside the square bracket, there's another 4. 4 times the sum of x squared. That's the number I just found, the 9,091. Minus, now notice this. That's the 9,091. What is this? The sum of x. Notice the squares outside of the bracket. That's where you take the original sum of x, which is 175, and you square that. That's not necessarily the same result. Okay, but that's what you do. That would go there, times 4n again. 4 times the sum of y squared. Okay, that's 199. Minus the sum of y. The sum of y is 27. Square that. Okay. Oh, and I need to remember that all this on the denominator when I'm done is under a square root. I have to take the square root. So I did some of these calculations. I get in the numerator. See if you get the same result, that this works out to be a negative 445. And in the denominator, that is a square root. Okay, this part of it, this half of it, I get 5,739 times this half of it right here. Are you getting the same thing? I get a 67, which is a negative 445 over, multiply those two things together, take the square root. I get 620.09 some odd. Or, now just do the division. This is negative then, right, as an overall result, 0.7176. That is the answer to the original question. What is the correlation between age of the moviegoer and score for the movie? The correlation is, or I should say the correlation coefficient is a negative 0.7176, which is to say, somebody was asking you what's the relationship between the age of the moviegoer and their score for the movie. It appears to be a fairly strong negative correlation. Okay, remember you can't get any stronger than a -1. We're kind of at 0.71, getting fairly close to that. It's a fairly strong negative correlation, meaning that the older the moviegoer, higher number for age, generally the less they thought of the movie, the lower the score. The lower the moviegoer's age, the smaller the number for age, the higher for the higher number for the score, or this particular movie, whatever movie it was, appears to appeal to younger audiences.